I'm going to do one of those things I never thought I was going to do, and that is build a ferrite type crystal radio. Yeah, I've got all the parts assembled finally. It's taken a while to put them together. The components are a ferrite rod and some holders for that. Now you can just use a block of wood with holes drilled in it. I will put the dimensions and all that I've used in the back end of the video. But yeah, you need like a block of wood with a hole drill in it, or you can print these or something similar. We're going to need the usual array of things like these fanny stock clips, screws, brass washers. We will need a variable capacitor, and I think that the best is somewhere in the 400 to 500 picofarad range. A bracket for that. I will put the 3D printed version that I've made, and also you can just use a piece of folded metal, obviously. Knob does not hurt. There's different ways to make those if you don't 3D print. Of course, we'll need our little magic diode, wire, and I'm using 0.2 millimeter. I don't remember what wire gauge that is, 32 or 36. I'll put that somewhere in the description so you can find that. Of course, the earphone, the crystal earphone, and then a piece of wood to mount it all on. So yeah, there'll be some other assorted screws and some tied together wiring and all that. But that's it. Let's look at the circuit diagram and then we'll start building. So here is our layout. It's rather simple. We'll come in here on the antenna. We'll go here to this connection point. So these two things right here will be fanny stock clips, and this will be the antenna. Now this is from an old kid's book on building crystal radios, and I'm going to make some modifications to it. The antenna winding, so this is going to be I'm not sure if this is considered loosely coupled or closely coupled because it's sharing the same ferrite bar, but okay, so it's a coupled antenna, and it comes up here. There's 10 turns of wire. I'm going to make this so it slides so we can change the amount of coupling and make it tighter and looser. And then again down here to the ground. The center portion, so this is the tuning part of the circuit. So this is the resonant tank circuit, and it will not be movable. A variable capacitor. I have a 500 picofarad. I'm not sure you need to go that high. I think it's more typical to get a 400. But this is what I've got, so I'm going to roll with that. It might take me a little bit outside of the AM range, but okay. I just won't, it'll be noiseless in that area. So that's that. And then over here, the same thing. This is the detector side of the circuit with the earphone. Again, I'm going to make this movable, and it'll be 40 turns of wire. These are the connection points. So these connections, I guess, these wires here have to be flexible. For the ones that move. So this one, this one, this one, and this one all need to be flexible. I will probably use the, what is that called? The wire wick, the solder wick for, when you want to remove something in soldering, because that stuff's very flexible. It's woven, it moves nicely, and it'll last for a very long time. So these are the connection points here. And of course, then we'll have the cat whisker, the resistor for the earphones, and finally the earphones. That's that. Some notes down here on wire size. So it is 32 gauge. The ferrite is 100 millimeter by 10 millimeter. So that's the whole length of the rod. And then of course the tap and connection points. So if you're going to build your own mount for the capacitor, for the variable capacitor, these are the dimensions I used for making mine when I 3D printed it. And then this is the mount for the ferrite rod, and it had a 10.5 millimeter hole in it. Now, I gave myself a little bit of slop because 3D printers aren't terribly accurate. The insides won't be smooth, and so I probably gave myself 0.5 millimeter. Okay, but the other dimensions over here are not critical. Usually once it's standing off the board. But otherwise, yeah, the hole is the most important thing. Okay, now the next thing to do is to build it. So the first thing I did was start to repair this ferrite rod. And I'm going to do this step by step, and I'm going to show you each step that I can, because this turns out to be a little bit more detailed than I thought it might. So here's where I am right now, but let me show you how I got here. First, I start out with a Ferrite rod, and these things are really rough, and I don't know if you can see that edge right there. It's sharp. So I took some sandpaper and I knocked the edge off and made this a little smoother. My original plan was just to sand it and spray it with a clear acrylic lacquer, and then wrap over it. And of course the two sliders would have to be on something else, on plastic or paper or something. So that was the plan, but something way back in my memory says that no, you're supposed to have paper down, and I found this professionally done, and you can see that there's paper right there all the way around it. Now maybe that's because they wind the coil separately and then shove it on here. I don't know, but in any event, I have rarely seen one of these that's not wrapped with paper. Okay, so back to the coil. I got it sanded, I got it sprayed. Then I needed to wrap it with paper, and my first attempt failed because I just took some copier paper, printer paper, and tried to wrap it around there, and it wouldn't go. I mean, because of these flat sides, it was all puffy, and if I had wrapped it with wire and it had a flexible surface, every time you touch the flexible surface, the coil would, how should we say, disassemble itself. Yeah, so what is the secret? Well, I took the paper off, then I took a new piece of paper, and I soaked it in water. And I mean, I really soaked it until it was dark gray. Then I slowly rolled it around this surface, and it just went on there beautifully. Now it tears very easily when it's that soaked, but yes, I just rolled it on around there, and then I sun dried it. And of course the edge, there's the seam right there. I don't know if you can see that, but the seam is right there. And no, it's not going to stick by itself. So what I did is I got a toothpaste and some white glue, and I lifted that a little bit, and I laid the white glue in there. I don't want the white glue out on this surface because it creates lumpiness and whatever, and I don't, using this final wire, it will cause the turns not to go on there smoothly. So now the next trick is I'm going to wind these 60 turns. Is that what it was? 60 or 45? I can't remember. I got to go look at my notes. So I'm going to wind the static set of windings next and put some contacts on here because the wire is just too fine to let it go flopping around or whatever. And then I will have to come up with some way of creating the sliders, which, yeah, I haven't thought that through yet. But anyway, one step at a time. Okay, so that is getting the paper on the Ferrite rod. I've got the 60 turns on here, and what I did is I had a rubber band that held down one end of it, and I just wrapped them across here till I finished, and then I put a rubber band on this end to hold it in place, and then I spray painted it with a clear acrylic lacquer, followed by, because it wasn't sticky enough, followed by a coating of white glue. And after that I put on some wire. You can see these wires right here. I bared off enough wire to go all the way around the ferrite, and then I tied them off here, and then I soldered the ends of the copper onto here and then here, and that's it for this step. Now the next thing I need to do is get my sliders on here, and I will do that with paper. First I'm going to lay down some of this Teflon white plumber's tape, and that will give me a little bit of spacing. So I don't plan on the Teflon tape staying on there forever, but that'll give me just enough room to allow this to slide back and forth easily. I will do the antenna side first, and then I will do the headphone side second, which has the detector and all that in it. But I can already tell you right now that this is not a beginner type project. It's already pretty complex getting all this done and stripping off the wire, and this fine wire is in some ways easier to lay down, in other ways it's harder to work with. So, but yeah, it adds another dimension to making this radio. Okay, next step, getting on these two coils on the sides. I'm going to do a half step here and show you what went wrong. The Teflon tape was a total fail. So what I ended up doing instead was using a piece of packing tape, and you can see it here. And this is sticky side up. So I rolled it around the ferrite bar, and then I rolled paper around that. So again, just copy your paper. And it sticks very nicely to the tape. And I started rolling it on there, and then I smeared it with glue and finished wrapping it around there. Put the rubber band around it to hold it. Same on this side. This is the packing tape. So this is just the stuff you use to close boxes with, nothing special. And again, same trick. Started the strip of paper on here, stuck it to the tape, and then glued it and finished rolling it around there. So does it move? Well, yeah, it slides nicely. When it's done, I will take a sharp knife and cut the tape here and then slide it off, the excess tape. But yeah, and the only trick here is, of course, you have to measure this for the width of your wire. So this side has 10 turns and this side has 40 turns. So in my case, it's 10 times 0.2, plus I need a little space for the connection points like that. And then on this side, it's 0.2 times 40. So the next thing I do is I wait for this to dry. I wrap the copper, I put my leads on there, and this will be done, and I can start on the rest of the board. I got the coil wound, so this is the main section, it does not move. This is the side with the detector, and the diode earphone resistor, and this is the antenna side, and they still move in spite of everything I've done to try to glue them in place. Yes, so that's working well. This one's a little tighter than this one. I wish this one were also as tight, but okay, so I got the wires soldered on here, and I've started laying out the board. I think this is the way I'm going to do it. I'm going to put the antenna and ground over here on this side, so these two wires will go to those. These two wires will go to the variable capacitor right there, and yeah, like that. It'll be on the edge of the board. And what else? So again, that's these two wires, and these two wires, they will go to diode, resistor, and earphone like that. And I'm going to leave this section open over here for a mineral cat whisker in the future, maybe. I don't know. Either that or someday I may saw this off. Either way. Okay, so the next thing for me to do is got it all laid out, and now I just need to go do it and finalize where I'm going to put the screws and everything, and then I'll be back. Here's where we are. I've got pretty much everything laid out. The coil is mounted, and in the two mounts that we discussed, again, you can use a piece of wood. Over on this side, this is the detector side with the earphone, and it will come out here. The brown wire, brown and white wire, will attach here. This is the diode. It will go from here to here. The other wire, the brown spotted white wire, will come out here and attach. I've got to get this out of the way, and attach to this point right here. And the resistor goes across here, and then the earphones. This is the one side of the main coil. It will come out here. I'm going to put an end loop on it, and it will meet another end loop coming from the variable capacitor, and ditto here. So here to here, and here to there. Finally, we have the antenna coil, which is right here, and one side, the dark blue with white, will go to here, and then the white wire with the light blue dots will go to here, and then we will give it a test, because that's pretty much it. Okay, here we are all done. First, I need to make a comment and a confession that I posted this video originally and said this thing doesn't work, that I could not even get a whisper out of the earphone. And a commenter over there who's smarter than I am pointed out that I cannot do what I did here and wrap these wires, these end wires. So these I brought up and I bared it off and I wrapped it all the way around and then soldered it, which makes a really strong connection. However, it's also a shorted winding. So it's just like having a transformer with a shorted winding in it. And I had 6 shorted windings across here, so of course the signal is not going to make it from here to here. Yeah, so don't do that. What I had to do is I had to go back with this knife and clip each one of these, cut it, and break the short out of all 6 of these. I will go back later and trim off these little things and then put a dab of epoxy there to keep it from pulling off. Probably not necessary, but you know, I like to overdo things rather than underdo them. Okay, so the main coil is done, and that caveat, don't do what I did. Don't wrap a bare wire around your coil because it'll short it. So here's our antenna hooked up. Here's our main coil connected to our capacitor. This capacitor actually has 2 capacitors in it. They're 2 270s. And yeah, so what I did is I connected both of them here. And that will give me a little bit too much capacitance. But I have the option, because of the way I wired this, I can disconnect one of them and use one of them if that works. I can use both if that's better, or I could actually come back, put a switch in here so I can switch one in or both in. Here is the detection side. We got our diode in place, we have our resistor in place, we have our earphone in place, and so now all there's left to do is go hook it up to the oscilloscope, connect it to the antenna and ground system, and tune through the stations. Again, I can't play somebody else's music or whatever on the radio, so we'll just look at the oscilloscope and I can show you the different stations in the area. Here we are connected to our antenna and ground, and you can see the coils back here from the antenna wires coming in. Here is our oscilloscope, and it's set to where I usually have it so you can compare to my other radios. This is the first station. This is usually a fairly strong station, and as you can see, it's not hitting big. I can adjust the antenna. Of course, that just makes it weaker. So there we go. Detector side. Doesn't have a lot of effect. Okay, let's try another station. Music, barely. There's somebody's voice with another station interfering. This improves the selectivity, maybe 5%, maybe. So not great. Yeah, I'm still getting a lot of crosstalk. Because the next thing we're going to see is the station that's overwhelming in this area. Yeah, here it comes. And it just, they're playing a song as they usually are. And again, probably 5% difference from extremes. And yeah, maybe 5% on this side, so not a huge factor. Let's see if we can get the other station that's towards this side, because you can almost always get 4 stations, and no, cannot. So this is picking up 3 stations. The more sensitive radios, the better sensitivity radios, have 5 stations they can pick up. And yeah, so I would love to tell you to build this, that it's a great radio, but frankly the sensitivity is poor and the selectivity after all this work is yeah, maybe give it a 5% better than the others. Okay, so this is a kind of a thumbs down on this after all that work. Well, hope you found that useful and interesting in your DIY crystal radio projects.